Okay, good morning. I'm going to work some exercises on, we got factoring practice to do, and we got multiplying, dividing rational expressions. I'm dividing up this rational expressions chapter into the, because of our test day was scheduled this week. So we're going to take the test only dealing with part of them, the multiplying, dividing part. And then we're going to handle the rest of the rational expressions after the test. Abbreviated version of the rest of the rational expressions and onto the other radicals and quadratics that we have still ahead of us. So that's the plan for this week. We got to focus on being good at the factoring and the simplifying that goes with multiplying and dividing these things. Also solving equations by factoring when you're using the zero factor property. So those are the major topics we want to look at now. Any questions you have all from this homework or the lab on this stuff are welcome. I'm going to work through some examples anyway. Get this set up. All right, so as we work through any of these kind of things, multiplying, dividing rational expressions, or solving equations by factoring, I should add that to the list. There's a factoring step in there, so built into all of those is going to be plenty of factoring review. We'll have a mix of those. It's part of the process here. So I'm going to start with a multiplication problem from here. Include the factoring that goes with it. See what else we can work with. I'm taking this out of the textbook now, our textbook, chapter 7, number 36. Z squared plus 3z over z squared minus 3z minus 4 multiplied by z minus 4 over z squared. That's how that thing starts out. I'm going to write everything in factored form and go from there. I want you all to be thinking in terms of categories of problems for this exam. Almost everything should fit into these 4 categories. Is it just a factoring problem? Is it solving an equation by factoring? Is it a multiplying or a dividing problem? Those are the categories. This is obviously multiplying rational expressions. I mean, these aren't hard to sort out, but if you think in terms of those 4 categories, then you should have kind of a plan of attack for all of those problems. Anything in that category. For the multiplying problems, our plan of attack is to factor everything, cancel common factors. The multiplying is really just this. It really just turns into one big fraction, but then we've got to do all of the factoring that we can on these separate pieces, write everything in factored form. And we expect some of these factors will cancel and we'll have a simplified form of it. So rewriting all this stuff in factored form. First thing I should think about in any factoring problem is GCF stuff. So if I look at this thing, is there a common factor from those 2 terms? Sure enough, there's a z that's a common factor. So yeah, I'll take that out. And then I have a 2-term thing that doesn't go any further. Here, there's no common factor. There's already no exponents on it, so there really isn't any more factoring to do on that. Once you've got no exponents and no GCF, there definitely isn't anything more to do. That's a factor already. This one, no common factor to those 3. 3-term factoring, regular 3-term factoring. The box thing would work fine for that. Or grouping. Some of you have been turning in the work with you like the factoring by grouping, where this is going to split up into those 2 terms. However you go through the process, these should be the factors that you end up with. These are the right factors for that one. So I'm just going to write them down. By now, if you've done enough of this pattern, you might be able to take simpler ones like that and just kind of think this through and write those down without writing out a whole process on it. That'd be great. Anyway, this is where you end up. And then z squared, 1 term. That's a monomial, so factoring is really just, you can think of them separately if you want. This is kind of overkill, but z squared is z times z. I can write them out that way. I do want to separate it out here because one of those is going to cancel. Right? There's a z multiplied on the top, and there's a z multiplied on the bottom. So those undo each other. I can take them off. Also, z minus 4. So from here on, the problem is just matching stuff up. Now that you have them all revealed, you cancel any common factors that you have from the numerator and denominator. And once you're done with that, just pull together what I've got left. All I have left on top is z plus 3. That stays on top. What I have left on the bottom is z plus 1 times z. I could leave those separated, or I could go ahead and multiply that out, distribute that out. Z squared plus z would be another way to write that same thing. Either of those forms, I think, is okay for the final answer. Answer keys tend to go with this expanded form of them when there's a multiplication. Both of those would be fine. That's the simplest form of that. Now, I wanted to note something on this that throws people off if you're not careful. Back in the early stages of this, we had some terms up here that are the same. These both have a z squared on them. These both have a 3z, although one of them is negative. But terms being the same thing doesn't really mean anything. That's added to this. I can't do anything about it. Okay, so that doesn't help me. The fact that those terms are the same doesn't really help me in this problem. Doesn't do anything for me. The only thing that simplifies is factors that are the same. So you got to get used to not thinking about terms now. Think about factors only for this. Like terms in an equation means something, but like terms in a fraction like this doesn't do anything for us. Comparison for that, again, if you have good arithmetic instincts, if I look at something like 236 and 219, they both start with 200 right here, but that doesn't really mean anything for me. If this thing simplifies, it's not because they're both 200 and something. It's not the same as 36 over 19, obviously. It's very close to 1. The only way I can simplify it is if there's a factor somewhere. So these common digits are like common terms. They don't help you at all. The only thing that does help you is factors if this one has common factors, which I don't think it does. This is 3 times 73, and neither of those go into this. So this one's 2 times 118. So 2 times 2 times 59. There's no common factors there, so they don't simplify the it's already in simplest form. Anyway, that's the analogy right there. Terms don't help you. All right, so plenty of factoring built into that. The different forms of factoring that we've done can all be useful in this, depending on what kind of polynomials show up. You might see a difference of squares, and all those show up in a lot of these. Difference of cubes or sum of cubes could show up. 3-term and 4-term factoring might show up in some of these problems. You got plenty of opportunities to factor stuff. Take another one out of the textbook and work this through, but then I want to think about some in the similar to what you're going to see in the homework, then I think these are. But I'll go to the homework exercises and pull some stuff out of there. I have had some questions come up out of there already. So review for the test. That is what's going on now. I mean, these are the 4 topics really we're going to have on this test. There'll be some regular factor problems, some solving equations by factoring, and some of this multiplying, dividing. And that's all that's on this exam. So narrows it down quite a bit. I want to do a division problem because those have come up quite a bit. Any questions there? Well, number 48 is pretty involved division problem, and that's good for you. Okay, so copying that whole thing down takes quite a bit of time, but I want to make sure you get it copied down right. That's the whole expression that I'm looking at. I'm trying to emphasize the categories that we're looking at right here. This is a rational expression divided by a rational expression. It's obviously a divide problem, right? That means I want to multiply by everything in factored form. But for the divide things, I like to go ahead and take care of the reciprocal part here also. So the factors of this one, this is going to get flipped over in the process. The 4 is going to go on top, and the factors of this thing are going to go on the bottom, because that's what turns division into multiplying, is this reciprocal that's going on. That's our math word for flipping this thing over. Reciprocal of a fraction. Flips it over, turns that numerator into a denominator. So now you can go through all the factoring and try to and then rewrite it as multiplied by the reciprocal. But I like to kind of combine those steps since I have to rewrite everything anyway. I will take care of that here. Now, as far as factoring goes, first thing to look for is a common factor. I'm going to do this thing. There's no common factor between v cubed and 8w cubed. There's no common factor. Next thing to think about, it's a 2-term factoring problem. So the only way the 2-term things are going to factor, if there's no GCF, is using one of our patterns. These are cubes. Well, v cubed is obviously a cube. So I'm thinking, and I could write this down because this is what I'm thinking of it as. That's a perfect cube. Is this one a perfect cube? And it turns out 8, cube root of 8 is 2. So I got 2w inside there. That's the cube of that. So this is definitely a difference of cubes. So if I remember the pattern for difference of cubes, the first short factor is just this minus that. And the second factor is this one squared plus this times that. That's 2w times v, or 2vw, if I write it that way down, plus this one squared. Now 2w times 2w is 4w squared. So that would be the factor in it. And there still has exponents in it, but this long factor that you get from doing sum or difference of cubes, this never factors any further. You can check it. This one's not going to factor any further. Moving to the bottom now, I want to get this in factored form. First question should be, does it have a GCF? 2, 4, and 8. I can take a 2 out of all of that. Right? So I got to recognize that. Otherwise, this will get you in trouble. A 2 should come out first. I want to see what's left when I factor out the 2. And then I should think about whether that thing factors. You could try the box thing out with that. You're not going to find numbers that work. If you did the numerator first, you're lucky. You're going to look at this and say, well, that's the same thing as this was. This thing that comes from the difference of cubes terms never does factor any further. So that's done. And it's just going to cancel here anyway. So we're going to get rid of that. but let me get everything written in factored form first. This one, no GCF here, two terms. These aren't cubes, these are squares, so it's a difference of squares form. This is 2w squared, so we're using that other difference of squares pattern is just a minus and a plus with those things. Now that everything's completely factored, I can do the canceling that's there. These are top and bottom of the same fraction. These are top and bottom of, well, top of this fraction and bottom of this fraction, but the multiplying means all this is being put together anyway, so it doesn't matter where they are. As long as they're the top and bottom, they cancel out. 2 and 4 have a common factor of 2, so I can divide by 2 here. And that's the only common stuff. There's not much left. Almost everything's crossed off. That's the nice thing about these, is they're set up so that a lot of stuff will cancel. You should have a fairly simple form at the end. 2 over v plus 2w is all I have left. So nice simple form of the result from all that division. Okay, I'm going to pull one other from this homework section, then I'm going to tie it back because I haven't looked at the equations using factoring. So I want to tie that in also. Okay, here's another way of writing the factoring or the division problem. It's going to look a little different. I want to get this copied down right, and so you don't get thrown off by the way this is written. I'll show you what's going on with this. Number 52 from the book here. Is written as a big fraction with fractions in it. It's actually what we call a complex fraction. I think you would agree that this is kind of complex, what I'm looking at here. Got a bunch of pieces. But if you've got a single fractional expression here, a rational expression here, and a rational expression here, then what that big fraction just means is it's a division problem. We're just dividing this rational expression divided by that one. So this is just another way of writing a division problem. That just turns into 3b squared plus 2b minus 8 divided by 12b plus 18. That whole fraction divided by this whole fraction. Now, has a lot of work rewriting it, but I didn't really do anything yet. But that's what these are. If it's written this way, it's just a division problem. Set it up as a division problem and do the same thing I just did, which is make it into a multiplying by the reciprocal problem. This one's just going to get flipped over here. Factors of this time. And normally I would go through factoring everything right now. I just noticed something about this. So I'm going to save a little work on this problem. Common factors are going to cancel anyway. This one, I'm not even going to bother worrying about what the factors are of that thing, because you see I've got 3b squared plus 2b minus 8 on the top and bottom now. Maybe it factors into separate pieces, but whatever they are, they're going to be exactly the same as what I have down here. So I might as well just cancel the entire thing. That's just going to cancel anyhow. I'll see what I got left on the others. 12b plus 18. No exponents there, but there is a GCF. Got to think in terms of the GCF here is 6. I guess I can pull out a 6. Yeah, 2b and 3 don't have any common factor left, so 6 is the GCF. That's the best I can do with that. And this one, the factors of this one go here because I'm doing a reciprocal. Factors of 2b squared minus 7b minus 15. Now that with the number out in front, that's a little hard to just write down. I'm going to go through a little factoring practice on that one. This thing, I'm going to go off to the side and factoring work on this. So you got like this way. You could do grouping. This is grouping. I just arrange it differently. The product is -30, and we got to think this through. Things that multiply to -30 and add up to -7. So that would be a +3 and a -10. So this would be a +3b and -10b. So common factors here are b minus 5. Common factor here is 2b. Common factor here is 3. Those are the factors of this thing. So that tells me this is going to be b minus 5 and 2b plus 3. If you're getting good at factoring patterns to where you can do some of this by just kind of trial and error stuff, you might have kind of guessed stuff that looks like this from here, especially since we're in this problem. And you might be thinking, hey, I bet something this is going to cancel with something over here because this is a textbook problem. They probably put some common factors in there. So you might have guessed 2b plus 3 would show up. And you can think about what the other terms have to be. Those work out right. So you might have found those by trial and error there also. Fine. You should get these two factors. You should stop and think, wait a minute, that's 2b squared plus 3b minus 10b, which combines right. And a minus 15. That all checks out good. Okay. So we're almost done. Have another common factor. And all that's left when I pull together what I've got left is a b minus 5 on the bottom and it's on the top and a 6 on the bottom. It's b minus 5 over 6 is all I got. That's a simpler form. And that means I like to stop and think about what stuff means after we've pushed a bunch of symbols around right here. That means any value that I pick for b, as long as it doesn't create some kind of zero denominator. Any number that I plug in for b, I could do a whole mess of calculations to see what that comes out to. But the result of all of that stuff is going to be the same as just taking that value minus 5 and divided by 6. So it's a lot simpler form of thinking about that expression. If b is 10, then I'm just going to get 5 over 6 from that. And that's a lot easier than dealing with b equals 10. In that form, we're going to have 138 and a bunch of other stuff to deal with. So, simplified form. That's what we're shooting for there. Okay, yeah, there is a lot of patterns with the signs when you're doing this factoring thing about pluses and minuses. Could actually do a little summary of that. Here's the things that might happen in the box for signs. Simplest case is when both of these things are positive. I'm not even worried about the numbers right now, but if both of those are positive, the product is positive. Your middle, the things that they have to add up to is either positive or negative. If everything's positive, then you use just positive stuff here. Or you could have a positive product and you need them to add up to a negative, in which case both of these terms have to be negative because negative times negative is positive. This is positive also. So those two things can happen. Or we have a positive here and a negative down here, then we get a negative product. Then we need these two things to be positive and negative. So it could either be, it doesn't really matter which is which, but it could either go this way around or minus and a plus. Those are the different forms you can get if your product is negative. They go back to stuff like this. This could be x squared plus 7x plus 10. If everything's positive, then everything's positive, and we're going to have a plus in both factors. If you have, I'm trying to think of quick examples of all of these. Something like this with the plus here and the minus in the middle. Both of the factors are going to need a minus. Then you're going to have a minus in both factors. Negative times negative is positive. That worked out for those. Anything that has a minus and a plus is going to have a minus in both factors. These things with the negative on the last term could be stuff like I guess you could set it up either way, but you're going to need, if you have the negatives here, you'll have a minus in this factor and the other one's plus. And if you have it set up where the negatives are in the row, you'll have a minus in this factor and a plus here. Those are really the four situations you could run into. So it seems like there would be some other patterns, but as long as your first term is positive, and we factor out a -1 if it's not, to make that first term positive. That first term's positive, then these are the only situations you should ever run into. So either you've got a negative row and the minus goes here, or you've got a negative column and the minus goes here, or you have sort of negatives on a diagonal. And that's when you use a minus in both of them. The patterns that'll show up there. So for this one that we did, minus, and it turned into one of these negative column things. I got a minus in that factor and a plus that I didn't write in the other one. Those are the factors there. Now, in a great big problem like that, where I'm dealing with factoring and rational expressions, I didn't really think about values of b that much. I'm not solving for anything. You can see those same kind of pieces show up in a factoring, in an equation. I wanted to do the tie-in to that. What if I had a solve for b situation involving that? Different kind of thought process at the end here, same factoring, but different kind of thought process at the end. And you got to separate that out because zero thing's important here. This is a different kind of problem. I'm using the zero factor property. Now, this is already written with the zero over here. If this started out with the terms kind of rearranged, I might have to deal with that first. This is the same thing as this. I mean, I just added 15 to both sides. So any of these things, no matter how your terms are arranged, I could have 2b squared equals 7b plus 15. All of these mean the same thing. They're just rearranged. And we can't deal with the factoring in those forms. We got to deal with the zero. First step is always to get it into that form where there's a zero here. So I got to rearrange my terms, minus 7b and minus 15, to have the zero on one side of the equation. That's got to be the first step if it doesn't start out that way. Down the factors already, so I'm not going to redo all of that. That's the next step on this, is to actually factor. 2b plus 3 times b minus 5. So if you're in an equation, you get 0 and then you factor, and then you use your property. The zero factor property is what allows us to break this up into simpler things, because for this products to equal 0, one of these things, so this is equivalent to that by this zero factor property. So you just solve out from there. You get a solution from each one of these things then. -3/2 or 5 should be the solutions to this equation here. Those should be the values that if you substitute them in here, they come out to 0. Two solutions to that equation. in the grand scheme of things, and this is something we're going to look at later on, but nice integer solutions like this come from factors that look like that. B minus 5 equals 0 when b is 5. So these things come from simple factors like that. Fraction solutions, rational numbers, come from factors that look like that, where you get the denominator from. So pretty simple factors that lead to the rational number solutions like that. If you're thinking, what if the actual solutions were irrational numbers and couldn't be written as a nice fraction? Well, that happens, but you're not able to do this by factoring then, because factors, we only use integers up here. We only get integers and rational numbers from it. If the solutions to the equation are something irrational, and it's not going to come from factoring. It's got to be done a different way. That's something we're going to tackle in a later chapter. Minus 3/2, and this comes from division. See, if you have a number with your b in the factor, you end up dividing by that. So I subtracted 3 from both sides. And then this last step is division. If you have a number with your variable, you're going to divide by it at the end. So you always get that fraction answer to that solution to what will come out to be a fraction like the negative 3/2. Now, longer factors that might happen here, or longer equations. I've done a bunch of examples where there's just the regular 2 factors to it. I want to think beyond that just a little bit what else might happen if I have equations. So let me set one up that does what I wanted to do here. Similar problem, going to be solving for x. Got 7x squared plus 42 equals positive 35x. Started out in that form. I want you to think about this. You could factor 7x squared plus 42 a little bit, but factors at this point doesn't help you at all, because I can't do anything with factors that equal 35x. I still don't know what the individual factors are. The only place in an equation where factors are going to help me is once I have the 0 here. So don't start 0 factor property without doing the 0. Right? The name of this thing is the steps of this thing. I have to get the 0 first. So I have to do some adding and subtracting stuff to get the 0 on one side before any of this factoring stuff will help me. So I'm subtracting 35x. It doesn't go with any of these terms. There's no like terms there. So I just have this long expression, 7x squared minus 35x plus 42. And I put that into regular descending order right there. I know I left one on the lab where the terms were out of order. The lab had one polynomial where the x term was kind of out of place. And I think most of the labs that I ended up looking at, I don't think that threw people off. You caught on to what was happening there. You have to, in order to set up either your grouping or your box thing, you need to have that x term as the middle term. You need to have them written in that standard descending order to do it. So people cleaned it up. But even though this one's in nice descending order, I'm not ready to do the grouping, the box thing with this yet, because I have to do GCF also. So I'm at the factor step. But the first thing I should always think about in a factor problem is there a GCF to this whole thing? And there is. 7 goes into all of those. So if I factor out the 7, I got x squared minus 5x plus 6. That's dividing the 7 out of everything. So I guess what I'm saying in this is you might actually have more than one factor stop. If it's a more complicated factoring problem, you might have to keep going. You want to get it completely factored before you apply the property. So this one's going to be a zero factor property problem. After the 7 comes out, I still have an exponent. I should still think about factors. These are, I'm just going to write them down now. These are a minus situation because you got the positive 6. So this is the one where the factors are both negative, and 3 and 2 are the numbers that work there. X minus 3 and x minus 2. And then the property says one of these factors has to equal 0. So either 7 equals 0, or x minus 3 equals 0, or x minus 2 equals 0. Every factor I got to think about right here. But if you're saying, well, 7 equals 0 is just nonsense, you're right. That doesn't happen. There's no solution to that. That's just never true. So there's no solution there. There is solutions, easy solutions to both of these. So those are both going to work as solutions to this equation. That one doesn't contribute anything. It's there, but it doesn't end up leading to a solution. That will happen on some of these where there's more factoring to do. Compare that. Here's the other situation that we could have. Let me set up one. I'm going to have some big numbers on this one, but that's okay. I want to start with a big looking polynomial. We're still solving for x in this thing. But I'm not taking this out of the book. I'm building an ugly one up here because I want it to turn out a certain way. So we got 18x to the third plus 21x squared equals 165x. All right, ugly numbers. Pretty big numbers. That's okay. If you're thinking there's a common factor on this left side and I could factor out a 3x squared, that's true, but not useful at this point. Do not think about factoring in an equation until you've got your 0, right? Keep it in order. 0 first. I got to do my 0 step. So minus 165x to the other side to construct 0 side that I want. Do that first. Actually, I want to put these in order. So the 21x squared would be there, and then the minus 165x. They're all unlike terms, and I'm putting them in descending order. Now I should think about factoring. Now I should think about GCF stuff. So 3 terms, but there's a GCF of 3. 3 goes into this also, yeah. And x, there's an x on every term. So actually my GCF is 3x. Factor that out. This divided by 3x is 6x squared. This divided by 3x is 7x. This divided by 3x is just a number. It's negative 55. Okay. Factor again, because I've still got some factoring to do in there. This is a pretty substantive factoring problem with numbers like 6 and negative 55, right? I could have 5 and 11 here maybe, or 1 and 55. One of them's got to be negative, but I don't know what the x terms are because it could be 6x and 1x or x and 2x and 3x. I don't know. A lot of factoring. So I'm actually going to stop and think separately about this factoring deal. There is no common factor left, so it's ready to be done. I'll do one by grouping because people are into that. It's not that much different from the box. We have to think about what numbers are going to work that add up to 7x. We have to think anyway about the numbers that multiply to this times that negative 330, but add up to 7. So that's pretty hefty. I'm going to need opposite signs because they multiplied in negative 330. So, oh wow. 3 goes into it evenly. Need stuff that adds up to 7, so they got to get sort of closer together with that. 4 doesn't go into it. 5 goes into it. 66 times 6 goes into it. 55 times. We're not nearly close enough. 10, 33. Wow, here we go. 11 goes into it. We're getting closer. 12. No, 12 doesn't go into it even. You can try that. Doesn't come out even. 13 doesn't come out even. 14 doesn't come out even. 15, I think, does. 22. Oh, there we go. I got one that adds up to positive 7. So if you're doing box, those would go in the corners. If you're doing grouping, this is what goes here. We just split up that middle term. That's what I'm trying to factor. That's the terms that it separates into. Grouping should work now. Three x factors out of these two. And 11 factors out of these two. And how lucky are we that these things matched up perfectly? That 2x minus 5 is a common factor that I can take out now. And when you factor that out, you get 3x plus 11. I'm kind of being, well, actually, we're going to deal with the equation over here separately, so I'm not worried about this now. I'm just trying to find the factors of it. I'm kind of being sarcastic. We were that these matched because that's actually what we were setting up when we found those magic numbers that work over here. We know they're going to factor out okay because the numbers work out like they're supposed to. So if you find the right terms in the middle, your grouping should work. This is the two factors that would. Let me put that back into my factoring problem. I got 2x minus 5, 3x plus 11. That's completely factored now. All the exponents are done. We're done factoring. So ready to use the property now. 0 factor. Keep factoring until you're done. And then use the property that says either this is 0, or 2x minus 5 is 0, or 3x plus 11 is 0. These actually all three have solutions now. This can equal 0. If you divide that out, you get x equals 0, which is a solution here. Or x equals 5 over 2 makes that factor equal to 0. Or 3x equals negative 11, so x equals negative 11 over 3. All of those are solutions to this one. If you plug in any of those, you're getting a 0 factor. You're going to get a 0 for the entire thing. So they're solutions to that equation. So comparing those, this one had 3 different solutions because all 3 factors had an x in it that I could solve for after using the property. Comparing that back to this one, I had 3 factors, but there wasn't any x in my GCF factor. That's what was different about that. That ends up not contributing to a solution. You have to think about every factor, whether it can be equal to 0, but sometimes they don't contribute a solution like that. All right, quick summary of where we're at right now. Those are the types of problems we've got to deal with. My other YouTube live session is going to be Thursday instead of Friday this week because that was in the announcement because I want to get it done before the test. Y'all are telling me what time slot works for you to take the exam So we're looking at either Thursday evening or Friday morning, or what did I say here? Friday afternoon is the third one. So it was in the previous announcement. Thursday evening starting at 8 o'clock, or Friday morning starting at 8 in the morning, or Friday afternoon starting at 1 o'clock. I have those time slots opened up for the exam that I'm going to send out the exams at the beginning of that time slot, and you're sending them back at the end. But you got to tell me which one. I'm hoping you'll be available at one of those times. Anyway, let me know which one works for you. So I have several people on the list already for particular time slots. Need others of you to let me know which one works. I'm going to be on live on Thursday afternoon for sort of last minute review. We'll go through some more of these, wrap up any questions that you have from this week's work. Didn't put a lab out for this week. Factoring labs are coming in from last week. I didn't put a lab together for this. We're just doing practice for the exam here, and we're doing the test this week, so I don't have another lab to turn in. But I want to go over questions from the homework or from any of the Lumen stuff that you're doing, and anything that you run into that doesn't work out nice, make a note of it, and or just send me an email about it, and we'll try to go through a bunch of those during the Thursday session. I'll get back to that. And then got to send me an email anyway. Tell me which time slot's good for you for the test. I'll be in those tests. We're ready to go here. So keep in touch. Have a good day.